Again, welcome to today's webinar, Introducing Amazon RDS for Postgres. Our presenters are Shrikant Deshpande, Product Manager for RDS Postgres, Shankar Lakhan, Lead Business Development Manager for Amazon Relationship Database Service. Shankar, you have the floor.
Thanks, Bowen. Hello and welcome, everyone. This is Shakil Langha. I'm a Business Development Manager for Amazon RDS, and then I'll be followed by Shrikant, who's the Product Manager for RDS Postgres. We are very excited to welcome you to our latest offering on Amazon RDS, which is the Postgres engine. This has been an engine which has been in very high demand. There have been a lot of customer requests asking for it. We announced the availability of Postgres at our reInvent user conference last month. And this webinar will walk you through some of the capabilities that we have to offer, the benefits, the features, and give you an opportunity to ask questions and understand what's coming next for Postgres. So with that, as Bowen initially announced, please hold your questions till the end. And if you have those questions, please put them into the chat box in your presentation. And we will take this up as we go at the end of the presentation. So I'm going to give you a very high-level overview, mostly focused around what is RDS in general, because there might be a few folks in the audience today that are new to RDS. And then Shrikant is going to walk you through all the details and the nitty-gritty of Postgres itself. So first of all, to give you an idea of what is RDS, it's been available as a service from Amazon for over 3 years now. And currently, so far, we offer a range of relational databases as part of Amazon RDS. We launched with MySQL. After that, we made Oracle available, then SQL Server, and like we are talking about today, Postgres is our latest engine. So the first thing you get from RDS is a flexibility in terms of your choice of relational database engine that you want to deploy on Amazon. You always have the ability to run databases just on EC2 itself. RDS offers a higher level of service. We abstract away a lot of the management capabilities. We provide a lot of the monitoring and do the heavy lifting to make cloud databases easy to run. And we'll talk about in the next few slides what those managed capabilities are. But in general, if you wanted to understand the distinction between what Amazon manages versus what you need to manage, what you need to remember is that the system administration part, the sysadmin part of a DBA's role is typically what's taken over by RDS. But everything that goes into building an application and optimizing it for your application, anything that you need to do in a database from a user or an application perspective, it's still your responsibility. So let's talk about some of the capabilities that RDS offers. And the first thing I want to talk about is basic stuff like backups and recovering from those backups. Now, this is something every database needs to do, every DBA needs to manage. If you have data that is required to be recoverable, then you put it in a database, and then you want to take backups and be able to recover from those. This is a task that is completely automated with RDS. Essentially, there's two types of snapshots that we take. One is an automated snapshot, which you set up on a schedule. It happens once a day based on the time of day that you pick. And it just happens by itself in the background. You don't even notice it. There's a retention period with these snapshots. So if you set a retention period of, let's say, 7 days, then we're taking daily snapshots, and as we take a new one, we retire the last one. That's an automated snapshot, and that has a retention period. On top of that, you can take manual snapshots. These are snapshots that you initiate from the account yourself, either from a command line or from the console. And these will stay in your account till such time as you decide to delete them. So if you want to keep weekly, monthly, even annual snapshots in your account, those can be done as well. Now, from any of these snapshots, essentially all you do is right-click on a snapshot and say launch a instance, and it essentially comes up as a new instance, which is a clone of this snapshot.
Again, welcome to today's webinar, Introducing Amazon RDS for Postgres. Our presenters are Shrikant Deshpande, Product Manager for RDS Postgres, Shankar Lakhan, Lead Business Development Manager for Amazon Relationship Database Service. Shankar, you have the floor.
Thanks, Bowen. Hello and welcome, everyone. This is Shakil Langha. I'm a Business Development Manager for Amazon RDS, and then I'll be followed by Shrikant, who's the Product Manager for RDS Postgres. We are very excited to welcome you to our latest offering on Amazon RDS, which is the Postgres engine. This has been an engine which has been in very high demand. There have been a lot of customer requests asking for it. We announced the availability of Postgres at our reInvent user conference last month. And this webinar will walk you through some of the capabilities that we have to offer, the benefits, the features, and give you an opportunity to ask questions and understand what's coming next for Postgres. So with that, as Bowen initially announced, please hold your questions till the end, and if you have those questions, please put them into the chat box in your presentation, and we will take this up as we go at the end of the presentation. So I'm going to give you a very high-level overview, mostly focused around what is RDS in general, because there might be a few folks in the audience today that are new to RDS. And then Shrikant is going to walk you through all the details and the nitty-gritty of Postgres itself. So first of all, to give you an idea of what is RDS, it's been available as a service from Amazon for over 3 years now. And currently, so far, we offer a range of relational databases as part of Amazon RDS. We launched with MySQL. After that, we made Oracle available, then SQL Server, and like we are talking about today, Postgres is our latest engine. So the first thing you get from RDS is a flexibility in terms of your choice of relational database engine that you want to deploy on Amazon. You always have the ability to run databases just on EC2 itself. RDS offers a higher level of service. We abstract away a lot of the management capabilities. We provide a lot of the monitoring and do the heavy lifting to make cloud databases easy to run. And we'll talk about in the next few slides what those managed capabilities are. But in general, if you wanted to understand the distinction between what Amazon manages versus what you need to manage, what you need to remember is that the system administration part, the sysadmin part of a DBA's role is typically what's taken over by RDS. But everything that goes into building an application and optimizing it for your application, anything that you need to do in a database from a user or an application perspective, it's still your responsibility. So let's talk about some of the capabilities that RDS offers. And the first thing I want to talk about is basic stuff like backups and recovering from those backups. Now, this is something every database needs to do, every DBA needs to manage. If you have data that is required to be recoverable, then you put it in a database, and then you want to take backups and be able to recover from those. This is a task that is completely automated with RDS. Essentially, there's two types of snapshots that we take. One is an automated snapshot, which you set up on a schedule. It happens once a day based on the time of day that you pick. And it just happens by itself in the background. You don't even notice it. There's a retention period with these snapshots. So if you set a retention period of, let's say, 7 days, then we're taking daily snapshots, and as we take a new one, we retire the last one. That's an automated snapshot, and that has a retention period. On top of that, you can take manual snapshots. These are snapshots that you initiate from the account yourself, either from a command line or from the console. And these will stay in your account till such time as you decide to delete them. So if you want to keep weekly, monthly, even annual snapshots in your account, those can be done as well. Now, from any of these snapshots, essentially all you do is right-click on a snapshot and say launch a instance, and it essentially comes up as a new instance, which is a clone of this snapshot. It's a clone of the database when the snapshot was taken. So you could have maybe production databases. You take a snapshot and then give them over every day to developers and testers. You can have one or more databases cloned and recovered. So snapshot recovery is very, very simple. Launching from a snapshot is almost instantaneous. It just comes up as a new database. It's directly usable. You don't have to wait around for it. So very powerful capability. Now, in addition to just regular snapshots, what we also do is, depending on the database, we'll copy over your bin logs, your T logs, your redo. We'll copy them to S3 every 5 minutes. And essentially what that allows us to do is give you the ability to recover to any point in time for any of our databases, for any edition, any version that is supported. Doesn't have to be enterprise, doesn't have to be, this would be, for instance, very similar to what you do with Oracle Flashback database, except we can do a flashback for, or we can do a point-in-time recovery for any edition, including standard editions. So in the case of point-in-time recovery, what we do is we'll figure out which is the nearest snapshot that we took, stand up a recovered database, and then play your logs forward till the point in time that you indicated and give you a recovered database back. Again, very, very simple, no heavy lifting required on your part. You don't have to pick up a phone, open a ticket or anything. You just right-click on a database and say point-in-time recovery. So with snapshots and recovery, the other thing I want to mention is very recently we added the ability to copy snapshots across regions. Essentially, when you take a snapshot, it just stays in the same region where you launched the database. But for DR purposes or for peace of mind or for whatever reason, if you want to, let's say, migrate from one region to another, you want to take a database snapshot that was created in US East and move it to Japan or to the European Union, that's, again, a point-and-click operation. You just specify the target region, and we copy over your snapshots, and then you can launch a recovered database in that region. So that was about backups and DR and recovery capabilities. Another thing I want to talk about is the ability to scale your databases. Again, something that you want to do in the cloud. If you launch a database and later decide that you have more users, increased load, your business is growing, you want to run that same database on a bigger CPU, on a bigger server with more memory. Or the reverse. I mean, you want to run a larger database during the day, but you want to run smaller ones at night or on weekends. Again, a very simple point-and-click operation. You just modify the database, pick a different instance type, and the instance type decides how much CPU, memory, and bandwidth you get on that instance. You pick a different instance type and say apply, and then depending on whether you want to apply it immediately or in your maintenance window, your database will shut down, come back up, and it's running on a bigger or smaller server. So just point and click, scaling your database up or down if you like. That's for infrastructure resources like CPU, memory, and bandwidth. If you want to scale your storage, you can grow your storage. You can essentially go from 5 gigabytes all the way up to 3 terabytes of storage. We offer 2 types of storage. There's the standard storage, and then there's also provisioned IOPS. With provisioned IOPS, you get very high throughput. On a 3 terabyte database, you can expect up to 25 to 30,000 I/O operations per second. That should meet, especially if you've got production workloads, very high throughput, high reliability workloads that require very consistent storage performance. That's what you want to opt for. So these changes are also point and click. You might have launched a database with 200 gigabytes. You want to now grow to 500 or a terabyte. Again, just modify database, give us a new number. And then you're not dealing with disks and volumes and LUNs and striping. We do all that. Storage is completely abstracted away from you. And all you do is you tell us what the new storage amount is, and we'll make it happen for you. You want to change from standard to provisioned IOPS. You want to change the ratio of provisioned IOPS. You want to go from a 5,000 IOPS database to a 10,000 IOPS database. All of those are zero effort, zero administration on your part. You just walk through the wizard, and it changes the performance for you. So that's in terms of scaling. The other very useful benefit that RDS provides is high availability and failover. Essentially, if you want a database that stays available no matter what infrastructure issues it faces, at launch, you just pick your database to be in a multi-AZ deployment. An AZ is essentially an availability zone. So if you understand the concept of regions and availability zones, we have multiple regions around the world. And within a region, we've got separate independent data centers. One or more data centers could be an availability zone, and these are physically apart. They're miles apart from each other, but they are joined together with very high performance, very high bandwidth networks. And they are they've got independent access to power and bandwidth, and they're meant to fail independently. So if you want a highly available database, you deploy it such that essentially all you do is you tell us that it's a multi-AZ database, and what we do is we'll stand up a primary database in one availability zone and set up a synchronous replica in a second availability zone. So essentially every time you write to the primary, it's also committed to the secondary before it comes back to you. And this entire setup, the standing up of the primary, the secondary, the replication, the monitoring to make sure that the instance stays healthy, the network isn't partitioned, the storage hasn't corrupted, we take care of all that for you. And if we detect that the primary has become unavailable for any reason, we'll take the DNS name of the primary and map it to the secondary database so that all your application has to do is attempt to reconnect, and within a matter of 1 or 2 minutes, it will connect to the secondary database, and from there it can continue processing and without any loss of data. So that's very critical, very important. There might be a slight blip for your application while it's not connected to a database, but it will not lose any data. And this will completely be monitored and managed by Amazon. And while we connect you to the secondary, we'll figure out what happened to the primary and stand up a secondary for you somewhere, again, without any intervention on your part. So very, very important capability that you want to use for any mission-critical type workloads. Let's move to the next topic here, and that would be security. So when you think about deploying databases in the cloud, when you think about putting sensitive data in your applications and making it available to the cloud, there is a misconception sometimes that, hey, all this is suddenly available to everybody. And so I want to walk you through the various layers of security that exist. At the core of it, every instance that you deploy on Amazon is surrounded by a security group. Think of it as a firewall, and by default, it will block any communication to that instance unless you specifically open up traffic from a port or from a IP address or traffic from another security group. So like I said, by default, everything is walled off, and you will only open communications for other security groups and for other IP addresses from where you want access to the database. That's the heart of the security. Besides that, you'll also have your database access and privileges, so you'll only have specific users with passwords that are logging in to your database. On top of all this, you can deploy your database in what's called a virtual private cloud. So that's a topic in itself. I'm not going to go too deep into that, but imagine a VPC as a private network that you can set up in the cloud. It's completely isolated from everybody else from a networking perspective, and you can actually make it an extension of your corporate network by doing a VPN into the VPC, into the virtual private cloud. So like I said, completely isolated from everyone else, but possibly an extension of your corporate network if you want it to be that way. And so that's a third layer of security on your databases now. Your applications on your databases would be deployed within a VPC from where nobody else can communicate with them unless you want that communication to be established. So a lot that can be talked about in terms of basic RDS features, but this webinar is focused on Postgres, so I want to take most of the time and reserve it for Postgres topics, and at the end we'll do Q&A if you like. So at this point I'll pass it on to Srikanth, who will continue with the details of the Postgres engine itself.
Thank you, Shakil. Good morning or good evening, folks, whichever part of the world you're dialing in from. My name is Srikanth Deshpande. I'm the product manager for RDS Postgres. I'll start off with, I want to keep this sort of interactive. So what I want to do on this slide is, today RDS for Postgres is available. The version we support is 9.3.1. And Shakil laid out all the benefits of RDS so far. So all that is available on day one with Postgres. And so, just to make this a little more interactive, what I want to start, I want to start by asking a couple questions. First is if some of you could share the size of your databases on your question window, that's something, and the largest size of your Postgres database, that's something we'd like to hear. And I'm looking for some inputs on the Q&A. And we've seen inputs at 500 gigs, 12 terabytes. Anybody can beat that? Yeah, I see the number of millions of records, about 180 million records is the largest we see so far. I see anywhere ranging from 25 gigs to 1 terabyte geographic data. We got 1.5 terabytes now, 2 terabyte databases as well. So I mean, so this kind of gives us a sample of people using Postgres for different use cases and the sizes of their Postgres databases. Now, if I may jump to the next question, I was curious if people are on EC2, if you're running Postgres on EC2, if you could share, the kind of instance sizes, and I can share what I see on my screen here, and that'd be something we'd like to know as well. Or if you're running, on premises, if you could share the CPU size or the RAM for the instances you have for your largest databases. We see M2X large, M1 large, couple micros. C3 instances, couple of them. 64 gigs of RAM, I guess running on their own instances. 8 CPU, 12 gigs of RAM. So that kind of gives us a sense of the instance sizes. And where I was going with this is, today the M1 instance types, as Shaquille mentioned, are available on Postgres, and we see all the way from micro to CR1 8XL, which is 144 gigs of RAM. And so we have the beefiest instances available on RDS, available on Postgres as well. So with that said, if you're already using RDS, I want to sort of get a sense of what is your most favorite feature on RDS if you're using RDS for other database engines. I'm waiting to see some responses here. Automated failover is one. Snapshots and restoration is something people have liked. All that's available on Postgres as well. Multi-AZ, that's available on Postgres as well. Backups, again, available like MySQL. Point and time recovery, available as well. So I guess where I was getting with that is, what you're sort of expected to seeing on RDS is currently available on Postgres as well. And read replicas is one thing that is on MySQL, RDS MySQL, which is not currently available on Postgres. And that's some feedback we've got from customers constantly. And it's sort of high on our priority list as well. And stay tuned for when we get to that point. Another quick question I wanted to sort of get some inputs on is the language extensions for Postgres. One of the questions I actually just got was PLv8 language extension, is that available? And that is not, but we'd like to hear, what kind of language extensions are you currently using for Postgres? We do see a +1 for read replicas. Yes, we hear you. In terms of language extensions, I'm seeing Python, PL/Perl. PL/Perl is supported right now. C is currently not. Python isn't either. PGSQL is supported from day one, so you can use that right now. Java, not yet. Untrusted languages are something we haven't enabled yet, and we've got some feedback from customers about supporting those, but being a managed database service, we have to constantly evaluate the requests from customers and be able to provide features while being fully in control of the managed database service to be able to provide fully managed services. All right. So we see a bunch of language extensions that are requested. So let me jump to the next few slides just to sort of give you an overview of how you can get started. I mean, this might be pretty basic for some of the people who have used RDS before, but people who are new to RDS and sort of getting started with the Postgres engine, I'm going to walk over a couple of slides. So the very first slide actually talks about DB parameters. I'm going to jump right in, but we'll go through some of the basic steps that come later. So, but wanted to give you an overview of what DB parameter groups are. So DB parameter groups help you choose and modify certain parameters specific to the engine. For example, on this slide, we see that the filter is actually set for connections, all the parameters that are related to the connections. And we see like 5 different parameters for Postgres that are related to connections in here. And if you look at some of the fields, some of them are empty, which basically means they're the Postgres default values. Some of them are forced or 1 or a 0, which means they are overwritten by RDS to values that make a lot of sense. And the next ones are a little bit of based on the instance size. These parameters are tweaked. For example, I can't quite read it, but the DB instance class memory is what the instance size decides, and basically you can set these parameters based on the instance class memory. And so what you can then do is use the same parameter groups across instances of different types and still be leveraging the same parameter groups across instances. With that said, I'll jump into literally walking through how you can create a Postgres instance today. So you can get started with the launching Postgres instance page. Now you see the favorite blue elephant right next to all the other beefier engines that we supported before. And so what this slide is about, so we see that Postgres has a beta tag to it. So some of the questions we've gotten around is, hey, is RDS Postgres ready for production abilities? And the answer is yes, it is ready for production abilities. The beta tag that you see right next to RDS Postgres on the detail pages refers to our ability to offer SLA. So once we are ready to offer SLAs or service level agreements, which say that we guarantee 99.95% of uptime availability on multi-AZ instances, we can guarantee once we are sort of comfortable with the fleet of RDS Postgres, we'll be able to offer that, and that's when we'll get into the beta tag. But as on day one when RDS Postgres was launched, it was production ready, and we already see certain customers launching their production databases since it comes with all the standard RDS benefits and the high availability benefits like multi-AZ and snapshots and all of that from day one. So what this screen does is, if you're using for production loads, we recommend using multi-AZ and provisioned IOPS. It sort of sets some of the defaults up for you. So I'll jump. So this is the next step in the launch process of the instance. We go over, you sort of create an instance name, a username and password. This is something that you want to keep safely for your use. The password is never stored on the web or UI interface. And when you want to connect to the DB instance, that's what you would use to connect to the DB instance. So we talked about the parameters earlier, and so this slide highlights the parameter group. So by default, there is a default Postgres 9.3 parameters that are selected. But if you would like if you have created your own parameter groups, you can choose from the drop-down list once you've created that parameter group to apply to that instance. In terms of the management options, so Shakil talked about your backups, snapshot, manual snapshots, and the backup window and maintenance window. All that can be configured to your own convenience whenever you think your application has the least access to database, maybe that's the best maintenance window you want to choose, and backup windows accordingly as to what time is the best suited for your application. And you can set the retention period in here, which is what Shaquille referred to. That's how long the snapshots are stored for before they're replaced with the latest ones. So once you go through all those steps, you're ready to launch the instance, and once the instance is launched, you kind of see the details of the instance, the endpoint, and it shows the username and the database name in here, the storage size, and all the details about the Postgres instance. In terms of, so the next screen shows a snapshot of using pgadmin to connect, if that's one of your favorite tools, web interfaces to connect to your database. This shows how do you get connected using pgadmin. You populate the host name and the password and username to get connected. So let's talk a little bit about the permissions. So all the folks in the Postgres, when you create an Postgres database, you're used to probably seeing the Postgres super user role. Since RDS Postgres is a managed database service, for us to be able to provide the managed services, we need certain access to certain system files, and we also will not be able to provide access to system files and system configurations to all the customers. So what we define is called as an RDS super user role. It pretty much mimics the super user role provided by Postgres, and lets you load and use extensions that are supported by RDS Postgres. It lets you view and kill sessions. It lets you create roles, alter roles, and all of that. Lets you create table spaces. However, it does come with certain restrictions which are which a super user role might have, but an RDS super user role might not have. For example, create language extensions which are not in the not defined in the RDS extensions list. That kind of stuff is sort of restricted in the RDS super user role. So let's sort of review what are the extensions that are really available. So we are really excited to offer PostGIS from day one. It's one of the most popular extensions out there for Postgres, and we see a lot of applications that are already leveraging PostGIS extensions on RDS. We also have a couple partners in the geospatial space who have leveraged RDS, Postgres, and PostGIS extensions to build geospatial software on top. And we'll actually get an opportunity to, if all goes well, I'll be able to share a video of one of our partners leveraging RDS, Postgres, and PostGIS extensions. So in terms of the extensions, there's a bunch of extensions we support here. I think here's something where I want to sort of open up the floor again and see if you can share which is your most popular extension, and if it's not on the list, it means it's currently not supported, but which is the most popular extension that you currently use from the list, and or even if it's not on the list, which is the one you would like to see. Would like to see some inputs on that. I think PG bulk load is one of the ones that people have asked, and that's not currently supported, but I see Tiger geocoder. We do support Postgres Tiger geocoder, if that's what you want. Fuzzy string match, yes, that's supported as well. PG stat statements is not supported currently, but would ideally, if it's very critical to you guys, would love to hear from you on your use case around it as well. Store is supported currently. That's one of the things people are. Postgres FTW isn't supported, but DB link is supported currently in terms of foreign data wrappers or being the ability to connect to other databases, foreign databases. PostGIS obviously is very popular. Auto-explain is currently not supported. PG crypto is supported, and that's one of the extensions people use currently as well. JSON is supported natively, so there's obviously a bunch of extensions in here. Earth distance, all that's supported as well. So the RDS extensions parameter is sort of the golden reference to what is supported on RDS Postgres. So I think we've seen a bunch of extensions requests and from various customers, and we'd love to continue hearing on that front to sort of be able to prioritize which extensions. And I guess this is, again, one place where we could even talk about language extensions, and if we've seen C and Python being requested by a couple customers, and if there is something else, you can add it to that list here. But the goal here is, we do try and support most of the extensions that are available with Postgres currently, but we're constantly evaluating the new extensions that we want to add in the future. So that said, I want to sort of give you a glimpse into what kind of performance we have seen using RDS Postgres. So this is literally a CloudWatch metric for performance that you can see for the IOPS. This is done with a CR1 8XL with, I think, 3 terabytes of storage and 30,000 IOPS provision. And you can see for that load, you see 16,500 read IOPS and 8,500 write IOPS can be achieved easily using the CR1 8XL instance type in RDS. So in terms of getting started, we walked through how to launch the instance from an AWS console. You get to configure the network, set up your security layers accordingly. You can load the extensions. There's a bunch of documentation you can go over in detail on the AWS Postgres documentation page, which talks about how to load extensions. And in terms of, I think one of the questions we've seen very often is, how do I migrate or export my database currently? And PG dump is what we recommend, to dump your database out, and PG restore to import it to RDS. So with that said, I want to sort of share some of the most frequently asked questions on RDS. I think the very first one is, does RDS Postgres support RAID replicas? The answer is no, it does not support currently, but we've got that asked from a bunch of customers, and we are obviously prioritizing our roadmap based on the requests we're seeing, and RAID replicas is on the top of our mind. How do I currently move my database from EC2 to RDS Postgres? Again, we addressed that briefly earlier. PG dump and PG restore is one of the quickest ways. And if you're trying to bring your databases from on-premise to RDS Postgres, if you are able to bring in it as a CSV file format, you can use the /copy to bring into RDS Postgres as well. So when do you plan to support, in terms of extensions, when do you plan to support extensions not in RDS extensions? Again, we are constantly listening to the customers and gathering their feedback on what extensions matter the most to them. A couple of language extensions have obviously risen up the list, and a couple of other Postgres-specific extensions have also geospatial-based as well, have come up the list, and we're constantly evaluating. But if you look at the RDS extensions list, it's pretty long, and hopefully, we will continue to add as we hear from the customers on that front. The other common question we've gotten is around connection pooling or log analysis tools like PG Pool, PG Bouncer, PG Badger. Do you support any of those natively? Currently, we don't support a lot of these. Currently, we don't support any of these tools natively, but we've had customers use them by connecting to the RDS instance and being able to use PG Pool and PG Bouncer, or being able to download the logs from RDS and run it on PG Badger to a certain extent. So that's sort of our current path, is to recommend continue using your PG Pool and PG Bouncer in front of the RDS Postgres instances like you're used to, and it should still work fine. So another common question we've gotten is, does RDS Postgres support mixed case usernames / database names? Yes, going forward, this is something we didn't quite support at the beginning, so people who've had mixed case usernames ran into a couple of issues, but we've addressed some of those concerns, and pretty soon you would be able to launch databases with mixed case usernames or databases with mixed case names as well. So with that said, I think that sort of glimpse into the questions we've seen so far and sort of what we've heard from customers. Now I think we're ready to take questions from your end.
Okay, so I'm going to curate some of these questions. This is Shakil again, and then direct them at Srikanth as we go. There are a lot of questions around extension support or specific feature support. So in case you missed the announcements, I'd recommend you go back and look at the recording and the slides, and you'll pick it up again. I'll address some of them as we go, but there's a lot of extensions out there. The one I want to emphasize is, yes, we do support PostGIS because it keeps coming up in the questions again and again. The other ones you'll have to, Srikanth mentioned a resource somewhere that you can look up, and then you have to go back to the recording to take a look at which ones are supported. Let me go through just some of the quick questions here. Is it best practice to run one RDS instance per database, or can you set up multiple databases under one instance? The answer is you can set up multiple databases within an instance, and this is true for all our engines. Sometimes there are limits, but ultimately it's for you to decide what gives you the best performance, how much resources a single database takes, and do you want to keep multiple databases within an instance or keep one database per instance and so on. So for you to decide. Questions around migration. So like Srikanth mentioned, it's currently dump and restore. We're always working on improving. With MySQL, we are currently supporting all kinds of replication mechanisms as well. So we'll work on those capabilities. Question around maintenance events and do they cause downtime, and is this information available from the API? So a few clarifications here. First of all, Amazon manages your maintenance. What that means is if there are patches, if there are upgrades to be applied, we will apply them on your behalf. These are done within your maintenance window. This is a 30-minute window once a week that you set up when you launch your instance, and you can modify it at any point as well. We don't perform maintenance very frequently. Maintenance that causes downtime, I would say we've maybe done it once a quarter or so. And in all of these cases, we give you a couple weeks of advance notice. I will send an email to the email address that you specified when you registered your Amazon account. So you get a heads up that there is a maintenance coming which will cause downtime, and then it only happens within your maintenance window, and it doesn't happen very frequently. Most of the maintenance is optional in the sense that it becomes available on your instance as a new version, and then you can apply it and upgrade to the new version whenever you like. There are some types of maintenance, especially security related, that we have to apply. They are mandatory. You cannot get out of those. But like I said, for those we'll give you enough heads up time for you to prepare. If you deploy your instances in multi-AZ, then the maintenance is done on the standby, and then we trigger a failover, so your downtime is limited in that sense as well. A lot of questions coming in, so I'm not sure how many we'll be able to take, but we'll try and answer as many as we can. With DB snapshots and automated backups, is it right that I'll need to pay for S3 storage used to store backups and snapshots? So the first thing you need to understand is when you launch a database, you're paying for the instance, the number of hours that you run the instance. And when you allocate storage, you said you wanted a terabyte of storage of the standard type of storage, then you're paying for the storage of 1 terabyte. That payment already pays for 1 terabyte worth of backup storage. Backups are snapshots that are done incrementally. So essentially, if you have a terabyte database allocated and you only have 600 gigabytes of data in that you change maybe 50 or 100 gigabytes a day, chances are if you set up your retention period of about 7 to 15 days, that entire set of snapshots will be less than the amount of backup storage that is already included in the cost of your instance. So the short answer is yes, you do pay for storage if it goes beyond that limit, but chances are you might not have to pay separately for it. Go ahead.
There's one question about how often do you plan on updating to the latest Postgres releases? I think that's a general question we want to address. Is we're obviously tracking the releases, and there is a minor update that you could set on an auto flag, and we'll inform you when we're ready to push that update out. But minor versions, we have the ability to auto update if you select that option. But in terms of major upgrades, we typically, if you've seen in the past MySQL, whenever the major upgrades have happened, we followed shortly after with an RDS upgrade on that version. But again, that said, the next version of Postgres, major version, is probably early fall next 2014, and we'll try and keep up at the same pace along with the Postgres releases on the RDS front as well.
Thanks, Shrikant. So another question around, with point-in-time restore, do we get multiple attempts if in the first round we pick the wrong point in time? So the answer here is any restore, whether from a snapshot or a point in time, launches a new instance. And you can have 20 restores going on simultaneously if that's what you want. So there is no wrong time. You can restore to as many points in time, and you can have as many restore operations going on simultaneously if you like. Are scaling IOPS and storage done without outage? So the thing to keep in mind, and there's other questions around here about, is disk resize without downtime? So scaling storage in general is without downtime, yes, especially if you just keep the same type of storage, but you just add more storage. Sometimes if you're scaling from standard IOPS to provisioned IOPS and the underlying type of storage has changed, that might cause a downtime, but it's very limited. But otherwise, most scaling of storage operations are without downtime. Another question around the 3 terabyte size limit per instance. The question is, what is the measure of that data? Is it input size, managed databases, on-disk size? So this is everything all told on that instance. It's 3 terabytes. You can monitor what the size is, but this includes your tables, your storage, your index, your data files, log files, everything else that's running on that instance, all told, should not be more than 3 terabytes if that's what you've allocated.
So there's a question about how do I pick the right RDS instance size if I've been running my DB on EC2. We have typically equivalent instances on the RDS front to EC2, starting all the way from micro to CR18XL, and hopefully if it's one of those equivalent instances, you should be able to match what you have on EC2 on RDS. However, of course, if it's a slightly different version on EC2, hopefully you'll be able to support some of those instances in the future, or you might be able to find an equivalent instance on the RDS and to run your database loads.
Okay, multiple questions around multi-AZ and synchronization. There's questions about how often do you synchronize between primary and secondary? Can you confirm if it is synchronous? What happens if I've committed a transaction on the primary and right then it fails? Can you verify if it's zero data loss? So the answer is yes. It is completely synchronous between the primary and the secondary. The fact that you wrote something and committed a transaction on the primary and it acknowledged that back to you means that it was acknowledged on the secondary also, because the response won't come back to you till it's written on the secondary.
There's a question around reserved instances. Will there be low, medium, and high utilization reserved instances like the other RDS engines? Postgres currently offers only high utilization reserved instances, and the reserved instance details and pricing are on the pricing page for RDS Postgres.
A question around, do we have middleware for load balancing? And there's other questions around sharding, so let me take that up. Essentially, these are cloud databases. There is limit to how much scalability you can achieve vertically. So ultimately, if your database grows beyond that, you're looking at some kind of sharding mechanism to grow your application and your database and the total storage. The mechanism for sharding is up to you. You have to decide from an application perspective what's right for your business as to how you go about sharding. You might end up with multiple databases, and then you need to it's still the application's responsibility to know which piece of data resides in which shard, how to grow them, and how to do either load balancing amongst them if you've got multiple databases with the same data and so on. If you need some software in between, that again is your responsibility, not necessarily applicable to Postgres so much, but if you have got read replicas and you want to do load balancing between them, let's say for MySQL, I've heard of customers using HA proxy and other mechanisms, but essentially it's still an application responsibility to figure out how to do load balancing, scaling, sharding with multiple backend databases.
There's a question around performance monitoring tools. What, if any, that would be available, and how do I, if I need to troubleshoot a perceived performance problem? I think CloudWatch metrics is what we offer currently in terms of performance. Obviously, you can use CloudWatch metrics to decide, and if you need further deep dive, we might, and it's something that you are not able to do it, we will be able to help you out in terms of if you can open a ticket for understanding a little bit more about the performance issues that you're seeing and give us some more details on that front.
So some questions around connection pooling. Essentially, connection pooling is a client-side responsibility. You've got to decide from your application perspective how you are pooling your connections and sharing them between various threads, various parts of your application. So that's not necessarily on the engine itself, but you can use any connection pooling mechanism that works for your application. You can use that with RDS as well. Another question around multi-AZ instances. How do you go about picking and pricing them? So essentially, if you choose a multi-AZ instance, that automatically means the primary and the secondary are accounted for. You will be paying for both those instances, and they'll be deployed automatically on your behalf. You don't have to separately calculate for multi-AZ. You don't have to separately deploy your multi-AZ instances or manage any aspect of the replication, the monitoring, the failover type stuff. All that is completely managed on your behalf by Amazon.
There's a question around, can we transfer reserved instances to RDS? This is something we don't currently support, but it's something, if you have a request, do send us a note, and we're taking into account of customers who have such a request. So we're still seeing a bunch of questions coming in. So
please discuss performance impact of Snapshot. So okay, this is important. A few things to keep in mind. Snapshots happen in the background, and they are taken off of your disks. You continue to have access to the database. You can continue writing. There might be a slight I/O pause as the snapshot is initiated, but the snapshot does complete in the background. If you're running multi-AZ instances, the snapshot is taken off of the standby, so that should further minimize the impact on your application. Having said all that, please do keep in mind that it's possible that certain write operations that you're doing, if they're directly touching the blocks that are being backed up, they might slow down your application. So I would recommend that you keep your backup window at a time when your application is not busy, and if you do run into issues, then let us know about it. How can we access the DB log? So Shrikant, questions around access to log files in general. Do you want to take that?
Sure. I guess